Hello and welcome to this video on Pico Diagnostics. This particular video is going to concentrate on how to carry out a very quick and simple starting and charging test using our Picoscope and the Pico Diagnostics software. Now before we take a look how to set up the software and how to run the test itself, we're going to take a quick look how to connect up our hardware that's required in order to run this test. Therefore, if you take a look at the video in the bottom right hand corner of the screen, you can see that I already have my test lead connected and that this is connected to battery positive and it's also connected to battery ground, and this is connected to channel A of my Picoscope. You can also see by looking in the video that I have my amps clamp positioned around the positive cluster of wires and that this is connected to channel B of my Picoscope. Now in terms of positioning our current clamp, we can position this on either the positive side or on the ground side of the battery, and the only real desired preference in picking which side of the battery we connect to is dependent upon the application in which you're testing and how easy it is to access either the positive or the ground side of the battery. So if we move on and take a look at the software, in order to carry out the starting and charging test, we simply click on the battery test icon, which can be found on the left hand side of the screen. This then opens up the battery test application within Pico Diagnostics, and this is what's going to carry out our starting and charging test for us. Now before we can click start and carry out the test, we do need to put some information into the software in order to get an accurate result of what our battery, our starter motor and what our alternator is actually doing. Therefore, in order to do this, we simply click on the options tab at the top of the screen. This then opens up the battery test options menu within Pico Diagnostics, and what we need to do now is input all the relevant information of what we're actually carrying out and what we're going to be doing. So if we start from the top and take a look, you can see that the software default has set our current clamp to 600 amps. Now if you work on commercial vehicles or heavy duty applications, you can, by simply clicking on this box, get the drop down menu in which you can select the 2000 amp clamp. However, on this application I am using the 600 amp clamp, so I'm going to stick with that one. Also, the software needs to know what sort of system voltage we're working on. Again, if you're working on a commercial vehicle or a heavy duty application, simply by clicking on this box, the drop down menu will give you an option of either 12 or 24 volts. Again, on this particular application, it is a 12 volt system, so I'm going to click on 12 volts. Now you can see the next option is an extended drop test. If you own a 4-channel Picoscope, you can also connect up channel C and D to the vehicle and carry out what's called the extended drop test. All you need to do is click on the box to enable that test. However, further details and information on this test can be found in the help section of Pico Diagnostics. The next option in which the software needs to know is what our unit of measurement our battery is. By clicking on the box, you can see that we get an option of SAE, DIN and EN. On this particular application, it is a EN battery, so I'm going to click on the EN option. The next bit of information the software needs to know is how big the battery is in which I'm going to test. On this particular application, it's a 380 EN battery, so I'm going to pop that in as 380. The software also needs to know, in terms of battery capacity, what our actual amp hours of the battery is. Again, on this particular application, that's 50, so I'm just going to input that in as 50. Now the next two options, which are currently available in Pico Diagnostics, will in the future disappear, and that's because the software will be able to determine these automatically and set these as appropriately. However, in the meantime, the capture time is there if we are working on a vehicle that has a smart charge alternator and it does have a time delay in which the alternator then kicks in and starts to produce charge back to the battery. We may need to increase this, and we can currently increase this anywhere up to 60 seconds. Our sample rate by default has been set to 50 kHz, and there is no real desired need to either increase or decrease this. The default amount is adequate for all the testing that you're going to be carrying out. So I'm just going to click OK to accept these changes into the software. The last bit of information the software needs to know is it needs to know what sort of temperature my battery is at. Therefore, the way in which I do this is by using a temperature monitoring device. I take the surface temperature of all the sides and the top of the battery, and I take the average of them all, in which this case it's actually 16 degrees. So I'm just going to drop this down to 16. Now in terms of our software, that's all been set up appropriately, and by clicking start I'm ready to carry out the test. So I'm just going to click on start now. You can see the software streaming, so all I need to do now is simply start the engine. You can see the software is now gathering all the data in which it needs. I'm just going to turn that off. if you look at the results, you can see that in terms of my battery's slightly low. I'm at 92% capacity, and it's advising a recharge, and that the battery is actually good. Therefore, if you were testing your vehicle and you got the same result, what I'd advise is that you recharge the battery and run the test again just to validate the battery is good. If we take a look at the charging circuit, however, we can see that our alternator is reportedly not charging. Now, if our alternator wasn't charging, we'd expect the vehicle A to be brought in flat, or B, there'd be a major default with our battery, and that isn't the case. Now, if you remember earlier, I said we can actually increase the capture time for alternators that do have a time delay. Now, this is one of those scenarios where we are actually seeing this. Again, in future builds, the software can do this automatically. However, if you do come across this, simply click on the Options tab again at the top of the screen. Increase the capture time. Now, if you look at the end of the screen, you can see that my alternator is just starting to kick in, so I don't need to add too much more time on. So I'm just going to double this up to 20 seconds. And I'm going to simply click OK to accept those changes, and then all I'm going to do now is simply click Start again and rerun the test. So you can see already I have a longer time across the screen. There's our 10-second cut-off point, and we can see it's actually around 12 to 13 seconds that our alternator has actually started to kick in properly. So by increasing the time, now the software's seen the alternator, so I'm just going to turn that off so you can hear me. So as I said, we can see now the alternator has been seen by the software. Again, it's advising a recharge of the battery. Capacity's dropped slightly because I have restarted the vehicle, but it's still reporting I've got a good battery just to charge it up. But now it's reporting I've got a good alternator output. I'm charging at 33% at 13.2 volts. Now that's how to carry out a very quick and simple starting and charging test using our Picoscope and the Pico diagnostic software. I hope this video has been of some assistance in helping you to carry out the test on your given application, and I thank you for your time. Thank you.